Okay, hi everybody. Now the thing that I want to do before we start talking about individual statistical procedures is I want to go over a broad roadmap of when you use the different procedures that you learned about in your statistics course. And I just particularly like this picture, and I included it in the handouts that you'll get when you watch this video. But I'm going to ask my assistant to zoom in on some elements of this while I talk about it. And then once we have a broad overview of how you choose different procedures to use based on what you're trying to find out, then we'll go into some more detail about some of these procedures after that. So if you wouldn't mind, just zoom in right here on purpose of statistical analysis. And so the first question that you have to ask yourself is, why am I doing a statistical analysis? And basically, there are three reasons for you to do this. One is, if you want to test whether or not there are significant differences between groups. Another is if you want to explore relationships between variables. And finally, another possibility is that you'll want to summarize univariate data. So I'm going to start with summarizing univariate data, and if you would, just zoom in so that you get this area right here. Now, remember that univariate means that you have one variable, and when you're just trying to summarize data, the kinds of things that you find are descriptive statistics. For example, I might want to know what is the mean and standard deviation of our students' test scores on the comp exam. And so when you're just summarizing data, these are the types of statistical analyses that you run. Okay, now scooch over a little to exploring relationships between variables. And the first question that you have to ask yourself is, what is your form of data? And if you would just, oh, well, actually you can leave the video where it is and just, I'll move this screen. So your form of data can be either frequencies or measurements, okay? And by frequencies, I mean number of observations. For example, how many Christians are in the program? How many Jews are in the program? Those are frequencies. Or you could have measurements. You could ask a question like, what is the IQ score of people in one program versus another program? Okay, stuff like that. Okay. Now the next level, and I'm going to go to frequencies now, the next level is number of variables. If you just have one variable, then you're going to be comparing that to a theoretical distribution and asking, is this just happening on the basis of chance, or is this the result of some kind of underlying reason why people are falling more in one group or the other? That's what the chi-square goodness of fit test does. If you have two variables, then that's a test for association between the variables, and that's when you would use a chi-square test for association. Now, I'm not going to go into much detail about how to actually do these tests. I'll choose some selected tests, and we'll go into detail about that later. But for right now, suffice it to say that you now should understand when you would choose these different procedures. Okay, now the next thing is if you have measurements, what kind of analyses do you do to explore relationships? If you have two variables, and you want to, for example, explore the relationship between height and weight, then you would ask yourself, what level of measurement is that? And height and weight are both interval. In fact, they're both ratio, but in any case, interval ratio data would get analyzed by Pearson's correlation coefficient, something that I'm sure you're all very familiar with. But if you go back up a level and go over here, if your level of measurement is ordinal, for example, the rank that you got on the comp score correlated with the rank that you got in your statistics class, that would be Spearman's rho. It's simply a different statistical procedure that would give you information about the relationship between ordinal data. All right, now go back up this decision tree and over to the idea of having multiple variables, where you want to find out the effect of two or more predictors on one dependent variable. For example, if you wanted to predict your comp exam score, and you input number of hours of studying plus number of total units of statistics courses in your history, you could then run a multiple regression to see if you could predict comp scores from those two predictors. Okay, that is a very brief overview, but that's why I like this, of the different procedures that you would use if you're exploring the relationships between variables. Now, I'm going to go over to testing the significance of differences. So the first question you ask yourself when you're testing the significance of differences is, how many groups do I have? If you have one group, then you would have this situation of comparing your mean to a specified value, and that would be a one-sample t-test. Examples of this might be if you want to compare the IQ scores of forensic students to the average IQ according to the WACE, you could do a one-sample t-test where you compare the means of our forensic students with the means of the population. If you have two groups, the next question that you would ask is, are my samples independent or related? Now, what does that mean? Basically, what it means to say that samples are independent is that you're not measuring the same person twice. Whereas if you're saying it's related, you are measuring the same person twice. This isn't a full discussion of independent versus related, but for our purposes, that's adequate, that you understand that. So let's say that you're in a situation where you're comparing aspirin to placebo for headache reduction. And you have one group of people with headaches in one group, and you have a different group of people with headaches in a different group. Those are independent samples. Let's say, though, that you have the same people, the first time they have a headache, getting aspirin, and the second time they have a headache, they come in and they get a placebo. That would then be considered a related sample. Okay. Once you decide whether you have independent or related samples, then the next question you have to ask yourself is, what form of data do I have? And remember the difference between ordinal and interval data. Most of the data that we look at, we're going to treat as interval data in psychology, and that would lead to an independent samples t-test. And of course, this should be very familiar to you. The ordinal version of the independent samples t-test is something called the Mann-Whitney U-test. And you should understand when you would use either of these two tests. This is something that we all need to know in our field. Okay, moving to related samples, same question about form of data. If it's ordinal, you use Wilcoxon matched pairs test. If it's interval, paired samples t-test. All right, now if we go back up and over to the area where we're still looking at testing significance of differences, but our number of groups is more than 2, so that we have multiple groups, we have another decision tree to look at. If we have independent samples, and I've already explained what that means, we go one way. If we have related samples, we go a different way. Next question is, how many independent variables do we have? If we have one independent variable, it's a one-way ANOVA. If we have multiple independent variables, it's a multifactorial ANOVA. And I'm definitely going to be talking more about ANOVA later on, but just so you know, this is how you would choose one of these tests. Let's say that you had 2 independent variables. That would be called a two-way ANOVA. Let's say that you had, to go back to my headache suffer example, let's say that you had people who suffer from a headache, and there are 3 levels of treatment: placebo, aspirin, or kick in the shins. That is just one independent variable. Don't confuse this and think that because you have 3 groups, you have 3 independent variables. There's just one independent variable with 3 levels, so that would be a one-way ANOVA. But let's say that you took that same experiment and you added gender as an independent variable. Then you would have a two-way ANOVA, because you'd have separated the groups, and there would actually be 6 groups. There would be male placebo and female placebo, male aspirin and female aspirin, male kick in the shins and female kick in the shins. Okay? Now, go back up past independent samples to related samples, and that's where you would implement a repeated measures ANOVA. Now, there's one thing that's not on this slide that really you are responsible for knowing and understanding, which is, when do you do a MANOVA? And the answer to that question is when you have more than one dependent variable, you do a MANOVA. And you could have a one-way MANOVA, a multifactorial MANOVA, or a repeated measures MANOVA. Remember that the dependent variable is what you're actually measuring. So in the headache example, if we also were to measure people's body temperature as well as their pain score, then we would have 2 dependent variables for every subject, and that would lead us to do MANOVAs. Okay, I really like this. I think it's very clean and easy to understand. The sources on the slide, but you're going to get this slide and you'll be able to review it at your leisure.